Welcome to Jackal DIY and Tech. In today's video, we'll do something else. And I have a new microphone. Well, I'm just using it from my main PC, which is the Samsung Q2U. I was using a lavalier microphone, which is a lot better to use when doing things like this because I can actually move around. But it doesn't work, at least at the moment. Why? Well, I did find the reason. The lavalier microphone has a TRRS plug, which has 4 poles, 4 pins, but this one that is currently plugged in only has TRS, so 3 rings instead of 4. This works, but with the 4 it does not, which previously it did. Anyway, what we'll be doing today is taking a look at basics in Arduino. So I have here two boards. This one is NodeMCU 8266 version 3, and also this one, which has a piece of wire attached that serves as an antenna, and this one is ESP32C3 SuperMini. And as you can see, it's basically 3 times, maybe 4 times the size of this one. And it mostly allows you to do the same thing as you can do on the big board. And I will be using this one because with this one, at least with the one that I have, it has USB, I think this is mini, and this one has USB type C. So at the moment I don't have any USB mini cables, so this is the one that I'll use, and I'll show you what you can also do. Now first things first, you will want to go to arduino.cc, download the latest version of Arduino and launch it. I already have this installed and launched. I guess 2.34 is available. I will not download it for now. Now I will connect the NodeMCU using this cable, which has the USB mini, but there will be some issues. Now this LED that I have put at the top will not do anything. I will be actually using it with the ESP32. Now this board is doing something, and that's because it's already programmed. And that's the issue with the cables. This one actually does not have data lines. So when you do make some code and you want to upload it to the board, if you get any errors that it cannot communicate with the unit, it's probably the cable. So this is the cable that I'll be using with the ESP32C3 SuperMini. And also, how much do these units cost? I think it's less than €2 with delivery, which is insane, because what do they allow you? Let's take a look at the pinouts, shall we? So just looking at this, we have an input with the USB Type-C. We have 5 volts, which could also be used as an input, but if you do use the 5 volt as an input, then the USB-C must not be connected. We have one ground. Really? Is it only one? Let me double check. That's about right. So on this chip we only have one ground. This one has at least, let's see, 2, 3, 4. This one has 5 grounds. Then on the ESP32 we have a bunch of digital signals, the 3.3 volt, and well, that's basically all we need. On the right side, on pins 20 and 21, we also have the data signals if you want to control something like a motor. And speaking of motors, that is also what you can control. I cannot show you this at the moment, but you can run this motor using something like this. This is DRV8225, I believe. So this is motor controller, and it controls the stepper motor. You cannot just connect this to power like 12 volts and expect it to turn. It does not work that way. it needs some kind of logic behind it, and we also control it with, you guessed it, an Arduino board, which in this case is this one. So this one spins the motor left and right or clockwise and counterclockwise every second or every 2 seconds, and this was just basically a test that I have done. Now I did record this previously, so if I find the footage, I will just put it on top of this video, so you can actually see what I'm talking about. At the moment I have this motor set up, so it just runs one circle in clockwise and counterclockwise direction, because this was just a test and it does need a bit more finicking than just what I have showed you with the LED. Now what this board and this one also have, and it's why I have the antenna, is they have Wi-Fi and Bluetooth. Now in my case, the phone that I have does not connect with the Bluetooth, because the Bluetooth that these boards use is BLE. So if your phone also does not support BLE, you will not be able to use it. And BLE is basically the low efficiency Bluetooth protocol. But you can use the Wi-Fi. At least you should be able to. Now one project that I'm working on, but I have no idea if this would be useful to like homeowners, it's probably meant to be used in industrial environment, is if a fuse blows. Usually at home we just have the fuse like switches, so they flip off and you flip them back on. But in industrial environment, if a fuse blows, you have to change it. And if you have a lot of fuses like that, it's a pain in the butt to find it. So what the idea is that a device will tell you which fuse has actually blown. And you can send that command using something like this. So a fuse blows, it sends the command here, and this sends over the Wi-Fi to your like Home Assistant, and the Home Assistant sends you then a notification on the app that a fuse has blown and actually tells you which fuse, so you don't have to guess among all the fuses that you have to replace. So if that is a solution that you need or know someone that would need it, let me know in the comments down below. Now let's get to the actual meat of the video. What can you do with the chips? You could maybe open an electric strike lock like this one. I'm still working on why I'm not successful with this, but basically you could send the signal. Now this is 12 volt, so you cannot hook it directly to the chips. You have to provide an external power to it, or at least boost it somehow, and you could basically open an electric lock. So I will just put it on top so you can see the chip, hopefully. So we now have this tiny chip. We have the Arduino downloaded and installed, but you can't do anything with it out of the box. What you need to do first is actually know which board you want to use. So in this case, we either have the NodeMCU, which uses ESP8266. So you will go to, in this case, let's see, first we have preferences. You will need to use a link for additional boards manager. This one is for the ESP8266. So you can simply find this. How? So let's see, just typing that out. Yep, we did get the link. But in this case, I need the ESP32. And in this case, it will be C3 SuperMini. Let's see if it finds the link. Yep, it does find it. And it does have to be this one, the expressive. So you would then simply copy this link, paste it inside here, and that's it. I'll cancel it for now because I have already done this. You will then go to the board manager, find either the ESP8266 and install it. I already have this installed, and the ESP32. As you can see, the ESP32 does come by default and you could install it, but this is for the Arduino Nano. I'm not working with this one, I need this one. So I do have this one installed. So this will allow you the communication with the board. And then you also have a bunch of libraries that you can install. But if you're a beginner and just want to know how something works, you can go to the file. Let's see, we have examples, basics, and the most basic one I think would be the blink, and also analog read serial. So let's open the blink one. Let's see what it does. So it has the pin mode LED built in, and this will be an output. And then it writes LED built in high, turn the LED on, high is the voltage level, and then it turns the LED off. But what I want is also to write something. So from this code, we can maybe print something out, which would be serial print, but you also have to initialize this command. So we have in the setup serial.begin. This will be the baud rate, which is then set inside here in the serial monitor. I will show you how. So I'll copy this, put it under the setup. So this will allow us to then simply print something out. So let me now copy this line, and just using these examples, I'll put the print lines behind or after the digital writes and before the delay. If you would put the print line after the delay, the LED would do the change, so either off or on. It would delay for 1 second, the text would then print, and immediately after the LED status would change. So basically, you would have the exact opposite of what the LED would be doing. So in this case, I'll just simply use LED is high, which by this code should be on. I will now copy this and simply put it below and change this to low. So that is done. Why is this not doing anything? Well, it's doing something, but it's not doing what this code is doing. Well, first you have to change the board. In this case, you can see at the top, we actually have NodeMCU. This is not the board that I'm using. So you have to go to Tools, Port. This is the USB that this is connected to. And we have an issue. I only have COM1. So what does this tell us? This tells me that this cable is only a data cable. And I will just show you what happens. So the only COM port that I have available is COM1. So you do have to select it. And then I will change the board. In this case, I have both installed, as you can see. From the ESP8266, the one that you want to use, at least if you have the NodeMCU version 3, is one of these two, so NodeMCU 1 or NodeMCU 0.9. If you have any other ESP8266 boards, simply find the one that you have. In case of this one, the ESP32C3Mini, the one that works, I'll simply go to the top with my mouse, press up, so I go to the very bottom, and the one that works is, it's the MakerGo ESP32C3 SuperMini. So that is now set up, and I can now upload the sketch. And if I upload it, we'll get this output. It's compiling the sketch. And now it wants to upload it using the COM1 port, and it will not be successful because it cannot communicate with the device, which means that this cable is also only for charging, and I have to find a new one. So I got this cable. This one should work because it came with a mobile phone, which means that the phone does not only charge, but you can also connect it to the PC to download the images and whatnot. As you saw at the beginning, a blue LED also flashed. On some boards I saw that the blue LED may not work, so if that's the case, you will just simply have to use an external LED like this one, and maybe you will also need a resistor to go with it. This one can take the direct voltage, other LEDs may not be so happy with it. So if I just show you, so this LED is directly connected to the 3.3 volt and ground. So you could hook it up like this just to test it out. But ideally you will connect it to ground on one end and a digital signal on the other. Now let us hook this up. So we'll go to tools, port, and now we have COM7, which means that the USB is actually transmitting the data. Select this one, upload the sketch. It should compile fairly quickly because it is a short sketch. And yeah, we now have compiling and also connecting with the chip. And the blue LED is now flashing, as you can see. Now if you're just a beginner when it comes to electronics and coding, and you only have an idea of what you want to achieve, but not how, what you can do? Well, you can use ChatGPT. So what do you want to do? Well, maybe instead of the onboard LED, we want to use that one. So let's tell you that. So it will tell you how to set it up. It also mentions that you should use resistor, a breadboard, and some jumper wires. That would be ideal. You do not need to use it on this board because it has throughput holes, at least the one that I have. Now this board also came with its own pins that you can solder in, but I thought that this would be a lot easier, at least for testing purposes. Now in this case it also offered the URL so you can install the package. This one is a little bit shorter than the one that I found, but it should work nonetheless. And now we have the actual code, CPP, I think this is C++. So we have to define the LED pin. It gave me pin number 2, so which is that? It's all the way here. Maybe I want pin number 4, which is closer to the ground. So I will use pin number 4 and I can simply define it with the number corresponding to the actual pin. So this is done like so. It will be number 4. Then we have to also enable the pin, so we will communicate with it. This is done in the setup, similarly to the built-in one. Maybe we can disable this one, comment it out, and instead of the LED built-in, we will use LED pin. That should basically be it. Let's upload the code. And also I did not show you what this LED is low and LED is high doing. And so we actually can see something. I also need to connect this doohickey. So the long leg will go into pin 4 and the short one will go into ground. The LED is blinking, as you can see. As for the text that we have input, if the LED is low or high, you can go to top right, open the serial monitor and choose the baud rate. In this case, we have defined it as, and yeah, as you can see, this is corresponding correctly. So when it is high, you would expect it's high and the LED is on, and when it's low, it is turned off, which I believe is the opposite when using the NodeMCU, because previously when I've done the test, when the LED was off, the text said it's high. So if that happens, just replace what the text says if you want to have this printed out. Now we have connected the LED, but this is how the signals work. So instead of just lighting up the LED, you can turn on motors. You give it a signal and it will spin in one direction or the other. And this is now an output pin, as we have defined it at the top, but this could also be an input. So do you remember what I've said in the beginning? If you have a blown fuse and gets the signal, well, that is how the signal will be obtained. you would define this as an input. So you would simply use the plus, connect it in this case to pin 4, and it would listen for the signal. And then you can maybe count how many signals it received, and based on that count, you can do some logic. Now what can you also do when you have something basic like this? Well, you can easily have an app, a mobile app, and you don't need to know much, really. You will go to RemoteXY, you can make your own custom UI, simply go to the editor and start making things. In this case, we could replace the code and enable the LED on the board using the app. So we could have a button, when we press it, the LED would turn on. The first thing that you need to do though is to go to the configuration. You will specify the connection. So in this case, my mobile phone only works via the Wi-Fi. In this case, the board is not ESP8266, it's this one, 832. The module is integrated Wi-Fi, and the IDE will be Arduino. So hit apply. Now in here I have LED and a button. The LED could also change, maybe to an orange one. As for the button, let's go with this one. And you can also type something in, maybe push. And as for the button, as you can see, it has snap to pin. In this case, we'll snap it to pin 4. So this should now activate the LED on the board, assuming my phone can connect to the app. So once you have everything set up, you'll then click on Get Source. This will give you the RemoteXY code that you can use. Everything that is not commented, this is a comment, that will be included. So this will be included, this will be included, and so on. The one thing that you have to know is this is the UI inside the app. What ChatGPT might offer you will not be correct and will not work. You actually have to make your own UI. And if you have to make any changes to it, well, I do not know how to change this code, so you will have to make changes using RemoteXY. I will now copy this section of the code and paste it at the top. So this is now basically the same thing. So we have to ask ourselves what we actually want. So maybe I will comment the LED section out. And then we have something in the setup. We have to launch or initialize the RemoteXY. So I'll now put this in the setup. So in the setup, you're initializing everything and setting the initial values. So in this case, the pin button 1, yep, that will be an output. So it's basically the same as this one. And now what we'll do is go to the loop. This is where the code repeats, and we'll simply enable or disable the button, or actually the LED. So let us go inside code. We don't need one delay, and we also don't need this one. So I'll just upload the code and go fetch my phone. Now how will I actually connect to the phone if it works? Well, we have the Wi-Fi SSD at the top. You can change this name to whatever you want. This will be the Wi-Fi that the chip makes. So either one of them, the one that you have, will make this Wi-Fi. It does not have internet connection. It just has the Wi-Fi connection. So any device can connect to it. If you have the password to it, by default it's 128. And you also have to have the port. Then on the phone, you have to install the RemoteXY application. Go to plus. You do have the Bluetooth option. As I said, these devices do not have Bluetooth 2.0. They have the BLE. My phone does not support BLE, so I cannot use this. So I have to go to Wi-Fi. If I select Wi-Fi point, it will say that it is off. So you do have to turn it on. and it may connect just to any Wi-Fi. So let's see which Wi-Fi this actually connected. It did connect to RemoteXY, which is this one, so that's good. It may also give you a pop-up that Wi-Fi has no internet connection, and it will maybe try to automatically disconnect and connect to a Wi-Fi that actually has connection, which did happen in this case. And that is not correct. As you can see, it connected to my home Wi-Fi. So it should give you a pop-up. It didn't in that case. Of course, now it did. So select it. Don't ask again. And yes, stay connected to this Wi-Fi. Let's see if now the Wi-Fi finds actually this device, which for some reason it does not, because my phone is, well, getting close to 8 years and the IoT things simply do not work with it as one would expect. And also maybe because I have installed custom ROM, who knows, maybe that could also be the issue. But I can show you a video of how I have done this previously using the NodeMCU, initially at least, but then I also could not connect to it again. The plus at the top, go to Wi-Fi or the Bluetooth. I can select the BLE, but my phone does not have it. And also I did not enable it in the code. So Wi-Fi, select Wi-Fi. Wi-Fi is turned off, so I have to enable it. Wi-Fi enabled. Select the Wi-Fi point. In this case it would be NodeMCU Wi-Fi. You also have to put in the password that you put in the code. By default this would be 128. It's connecting, and this now basically says the fuse is working. You see it? You do. So let me leave the phone here. So let me just touch the pins a bunch of times. So 6 times the fuse should blow. Why does it not report it immediately? Well, because it has a 10-second cycle. So now the fuse has blown and it mentions that inside the app. So you could also have push notifications if you needed that in the app. Now you can also scan the code. So maybe that is what I'll do if I'll have any luck. So let's see. Associating Wi-Fi device, and I guess it somehow cannot associate with it. I guess my phone is just not up to this task. Now about range. Last time I've tested it, at least on the Bluetooth, not with this phone anyway, it was more than 10 meters, but it was not with this antenna, it was with an actual antenna that had a bit of a cable attached to it, so you can get some good range out of it, but it does depend on what you want to achieve. But I did also test the Wi-Fi range using exactly this chip, and it had the same reach, which was awesome. So more than 10 meters, and mind you, this was not a straight line, so connecting to the RemoteXY is sadly not going to work. But if your phone is up to the task, you will simply have the UI that you have built here, and in this case, if you push the button, the LED should turn on. So we have pin button 01, which is the LED signal, so that is correct. And we have the button 1, which is this one. And we also have the LED, so we have button 1 and LED 1. Oh, the LED 1 basically does nothing because I didn't say I want something to be done. So it's this LED, this one would just be off. But the button 1, if it's like low, meaning it's 0, turned off, it's low, then the LED, this one, would be turned off. If the button was pushed, this would be 1, meaning it's high, and the LED would turn on. as long as the button is being held down. One thing that I did not mention, and I actually did not ask ChatGPT about this, as I can see, is that you need RemoteXY. As you can see, where is it included? We have include Wi-Fi and we have include RemoteXY. What is this and where do you find it? Well, this is a library. You'll find it here, books icon. So you can type in Wi-Fi. I should have some Wi-Fi installed. Maybe just select this to installed. So I have this Remote XY installed. So you do need this installed. You would search basically for Remote XY. This will show up. As for the Wi-Fi, maybe that is why it's not connecting. Because I should also install a Wi-Fi, I would expect. So let me just ask if that is the issue. Maybe I do not have a library installed. Though in that case, I would expect the code to not compile. But also the compiler does not give you all of the answers of what the issue is. So in this case, the Wi-Fi.h is already installed alongside the ESP32 board manager that I have added. So this should work. Though as I said, I guess this depends on the phone that you use. In my case, it is just not up to the task. So that's it for this video. It was basic, but I hope you learned something. And if you want to know more and what you can do, well, in the next project, I will most likely show you how to connect this camera to this board and have it automatically take pictures. So why you would use this? Well, you can use it for something like this, automatic photography turntable. This is basically what this person has done, though in this case, with this camera I cannot use radio frequency, so I have to use direct connection using this connector. I did test it out and it does work, so it's quite simple. So if you want to know how to do it, I will show you in the following video.